Hi YouTube, this is FP2 2012. Question 1, inequalities, the modulus of x squared minus 4 more than 3x. So solving for x squared minus 4 equals 3x and minus 3x gives these critical values. Testing between these values, we can see that x must be less than 1 and more than 4. And the sketch here shows x less than 1 and more than 4. Question 2, polar coordinates. Are given a polar equation and some information of a tangent to find the length of OP. So considering polar coordinates, the y coordinate will be r sin theta. So substituting our polar equation for r gives an expression for y, and then considering the tangent is parallel, then dy d theta will be 0. Differentiating and substituting an identity simplifies to a quadratic. Completing the square gives 2 solutions for cos theta. Ignoring the negative, then cos theta is minus 1 plus root 33 over 8. So considering the length of OP will be given by the polar equation, then substituting our result for cos theta gives the length required. So our result for cos theta and the length required. Question 3, complex roots, expressing the complex number in the form r cos theta plus I sin theta in A, and expressing the roots of z4 equals the complex number in the form r cos theta plus I sin theta in B. So for part A, to express in this form, evaluating the modulus and the argument, we can write down the form. So the modulus evaluates to 4 and the argument to 2 pi over 3. So we can write down the form. So for part B, substituting the right hand side obtained in A, considering by De Moivre's theorem z to the power 4 will be z equals 4 to the power of a quarter, this expression. But considering solutions for z equals 4 cos theta plus I sin theta equals the right hand side, to satisfy this expression, cos theta will be minus a half or root 3 over 2. And to satisfy both equations, then we'll give 4 unique solutions. And dividing these solutions by 4 and substitution in the starred expression here will give our 4 unique roots here. So the modulus of z and the argument of z and the 4 roots. And the complex plot here shows the 4 roots. complex plot evaluates the modulus of z and plots on the z-axis. And looking down on the xy plane, you can see the four roots here. Question 4, a differential equation. So solving the auxiliary equation, we can write down the complementary function. From observation of the equation given, implies a particular integral of c cos t plus d sin t. So differentiating and equating the coefficients of the differential equation gives c equals 3/10 and d is 1/10. So we can write down our general solution. So the auxiliary equation and solving for c and d and our general solution, and using dsolve, our general solution. Going on to question 5, a series solution to show the expression in A, and then a series solution given y equals 1 at x equals 1 in ascending powers of x minus 1 and b up to x minus 1 cubed. So differentiating in A, applying differentiation to equation 1 and simplifying gives the proof required, equation 2. So for the series solution 2x cubed, applying differentiation again to 2 and simplifying to here, and then considering minus 2 dy dx can be written as minus 2 dy dx squared, gives equation 3. So given the values of y equals 1 at x equals 1, substituting in equation 1 gives dy dx equals 4, and then into 2 gives 7 and 3 gives 32. So given these values, adjusting Maclaurin's theorem to x minus 1 and substituting our results to x minus 1 cubed gives the series required. So the series in B. Thank you for watching. I'll start question 6 in the next video.